Hello everyone. Today I will be demonstrating how to create a Microsoft SQL Server Availability Group cluster in the Amazon Elastic Kubernetes service. I will be creating 3 SQL Server instances, each running in a different data center. They will be grouped together into an availability group with synchronous database replication, achieving a sweet spot of high availability and disaster recovery for your precious data. The setup and management of this availability group will be performed by DxOperator by DH2i. The Kubernetes cluster is going to be named EKS2, and it is running Kubernetes version 1.29. We have gone ahead and provisioned this cluster with 3 worker nodes. And I will show you here, they are running in EC2 with the T3a X-large instance type. This was chosen because it has 4 vCPUs, which is a minimum recommendation per SQL Server workloads. And now I will jump in here and show you that these instances are spread across 3 separate Amazon data centers. Click on Instances. Yeah, so as you can see here, we have them in the US West 2A, 2B, and 2C. And also running in the same cloud is a Windows client VM, which we are using to run the demo here. This is chosen to keep it within the same network as the Kubernetes cluster for access to SQL Server to demonstrate connecting to it and such. Alright, so moving on, we will show the cluster from the command line using the kubectl command git nodes. And as you can see, we've got the same set of nodes we were just looking at. And you can also see that there isn't anything running other than the stock Kubernetes service on the cluster right now. The first thing we will do to prepare this cluster is to install the DxOperator by DH2i. This is a package that is installed via a manifest downloaded from the DH2i website. I have gone ahead and placed it here on the desktop, and I will go ahead and apply it. And we can watch this roll out with this other kubectl command. So there we see it's working on it. Should just be a few more seconds. And there we can see it is all done. So to speak a little bit more to this cluster, it has not been configured substantially beyond blank slate. It has had the EBS storage driver added to it, and that is all. And now it has had the DxOperator added to it as well. The EBS storage driver is kind of a minimum requirement for this type of SQL Server workload. Alright, but now moving on, the manifest that I will be applying to create the availability group is right here. This manifest is primarily the DX Enterprise SQL AG type object. This is a custom resource that is used by the DxOperator, and it defines all the parameters of the availability group. We will be naming it DXE SQL AG. We'll have 3 synchronous replicas and no async or configuration-only replicas. The name of the availability group within SQL Server will be AG1, and we will see that later. We will use the contained option when creating the availability group. This causes SQL Server to create shadow databases for masters and MSDB so that logins and such things get replicated to the secondaries. This way, you don't have to create logins specifically for all of your accounts in order to access them on secondaries. Then we will not have DxOperator create its own load balancers. Instead, we will create our own custom load balancers to fit with EKS. The DxOperator creates 1 pod per replica, and the pod template looks like this. As you can see, it has an NS SQL Server container, and of course, it also has a DX Enterprise sidecar container. The DX Enterprise sidecar container is a high availability management component. It monitors the health of SQL Server and all of the other members of the availability group. When it detects a need to, it will fail over the AG primary to a different pod. And it gets its image from Dr. Hub. So the last thing we'll do is accept the in-user license agreement for DH2i. There's also a cluster secret for DXE that has some runtime parameters. It has the cluster pass key and the license key, and I will go ahead and apply that right now. So here we go. Here is our passkey, and here's our license key we've pasted in there. We also allocate storage to DX Enterprise to store its configuration and cryptographic keys so that it can join the group. For the MS SQL container, we pull the image from Microsoft, and for this demonstration, we will be using the latest. For a production situation, you would want to pick something more specific and manage your upgrades. There is also a secret that gets created for MS SQL Server. That secret contains the SA password, and I will go ahead and apply that right now. So we will pick something that meets the complexity requirements. There is also an accept end-user license agreement option for SQL Server that needs to be set to true. There is a product ID. We will be using developer for this demonstration, but for production cases, you must use an enterprise or standard paid product ID. There is also a storage volume attached to SQL Server, of course, for its database files. We will be creating a 4 GB volume for SQL Server, and we will not be setting a storage class. The recommendation in EKS and EC2 in general is to use the IO2 type storage, and there are ways of configuring that in EKS, but in the interest of simplicity, I will be omitting that just to get things off the ground quickly. And something else that is necessary here is a topology spread constraint. This tells Kubernetes to ensure that when it creates the pods for this availability group, that they are spread across worker nodes that have different zones. This prevents more than one from being in the same zone. So if this were not here, Kubernetes may very well schedule 2 of the pods on the same worker in the same data center, which is not what we want. That concludes the primary configuration of the availability group. Additionally, we have these load balancers. Amazon AWS, like most other public clouds, has a concept of a private network that you can create and attach VMs and other such things to. And the load balancers by default inside EKS will make the service available on a public internet accessible IP address. But what we are telling it to do here is to only make it accessible in the VPC network, that private network among all of the VMs that belong to the AWS account. That way, we can access it privately from this Windows VM and not expose it to the public internet. And if you have other consumers of SQL Server apps, they would run in a VM alongside it and they would access it much the same way, with SQL Server very much being a back-end service. But we set this annotation on the load balancer to force it to be internal. And we set the name of the pod that it attaches to. And then we open up 2 ports. We open up a port for DX Enterprise Management and for SQL Server. We create 3 of these. We create 1 per pod of the availability group. And this is the entire manifest that we will be applying. So I will go ahead and apply it. And then I will watch it apply with my kubectl git pod command. So right now it is creating the containers and the different pod components. The load balancers take a little while to finish establishing themselves, but we will be watching the progress of this before they are done, and we will be doing so using a port forward. Now I can connect to the DXadmin administration console to the 0 pod and watch it from there. So it is almost done. It is still forming a cluster. They are not connected yet. Still working on it. Then there we see connected. Then synchronizing. Then synchronized. Now our cluster status is green. So now the next thing I'm going to do is connect SQL Server Management Studio. We will use the load balancer because it is established by now. So we will connect to that. And we will input our login and password. And we will set the encryption option here to optional and connect. So then I'll go into always on high availability. We can see the AG1 group that we created, and we're going to look at the dashboard. So you see here, this is exactly what we saw on DX Enterprise. It is established as a 3-node availability group cluster, and everything is healthy. Alright, so now the next thing I'm going to demonstrate is a manual failover. So I can connect to the load balancer. And now we can see it from there. We don't need to use the port forward anymore. Oh, okay. So now what I'm going to do is connect to the primary DX Enterprise pod and send a failover command. Failover command is using the DX Enterprise DxCLI tool. And we can watch it over here. It is shutting down the availability group, moving the host, and starting up the availability group on the new primary. We can see everything's connected, synchronizing. Then there it goes, cluster status is green. So let's take a look at SSMS over here and see that it is now a secondary. Then we're going to connect to our new primary, which is the 1 pod. So we'll connect to that 1 pod. Go to always on high availability and show the dashboard. Here again, you can see this is exactly what we see in the DX admin console. Well, thank you very much for watching. Please head to DH2i.com if you'd like to learn more, or to download a free software license to give DX Enterprise and DxOperator a try.